For this lesson, we're going to be looking at algebra tiles and how they can be used to help us, specifically when we're dealing with quadratic relations. So a couple of things, in case you're not familiar with algebra tiles, there are actually a few different types. The most common type you'll probably see in our classroom are going to be these red and blue tiles. The way I tell students, the way to remember this, red tiles represent positive. That means they're hot. So red represents hot. Blue represents cold, which is cold temperatures. Here in Ottawa, those are negative temperatures. So hot, positive, cold, negative. If you have a tile and you have to change the sign of it, the way you do it is you switch the color. So if I have a positive x squared tile and something causes me to change the color of that tile, then I would swap it out for the opposite color. If I needed to switch the sign of this one, I would swap it out again with the opposite color. Okay, now the best way to do this, there's not a lot of theory that goes along with this. Algebra tiles are a tool that we use to supplement our understanding of work in mathematics, and in particular we're going to be looking at it in terms of quadratics. So let's dive into some examples. So this first one, just simple addition. If you can do this algebraically, that's fine. That would be my hope, but I just want you to start to get an understanding of how these work with algebra tiles. So what's going to happen? 2x squared is in one of my brackets, so I bring down 2x squareds. Negative 3x. So when I'm doing these ones, I'm just adding, subtracting. It doesn't actually matter which shape you take, so I'm just going to take 3 of those. And positive 1 or plus 1. And then I'm adding to that, and I'm going to treat each bracket separately. So I'm adding to that an x squared minus x minus 4. And then I join all of these things together, or I group all of these things together to come up with my answer. Now in coming up with my answer, something you might notice, I'm just going to lump things over here, I have this situation. And one thing, whenever you have a positive and negative of the same tile, notice I'm adding these brackets, so nobody's changing any signs here. So I have a positive and negative of the same tile. Those would disappear going into the garbage can. Unfortunately, my garbage animation is not working quite right on this machine. And so they cancel each other out. They add up to 0. And that leaves me with my final answer, which would be I have 3 of the x squareds, and I have negative 4x's and minus 3. So that is my final answer using tiles. Here I'm going to introduce the idea of changing signs. So let's start off with what's in the bracket. 1, 2, positive 3 minus 2x. I'm just going to simulate the bracket here. That is what's in the bracket. So that means that negative sign applies to the whole bracket. That means change the sign of everything inside that bracket. So the way I would do that is those positive 3's, the 3 positive 1's would become 3 negative 1's, and the 2 positive x's, the 2 negative x's would become positive x. So the negative sign applied to this bracket becomes this, and now I write my final answer here. This is 2 positive x's and 2 positive x's and negative 3. So the final answer of 3 minus 2x is 2x minus 3. You can see the negative 2x became positive 2x, the positive 3 became negative 3. What about a multiplication? So let's start off gathering the tiles that are inside the bracket. So I've got an x squared, I have positive 2x, and I have negative 3. And let's see if I move these a little bit. So that is in a bracket, and I have negative 2 of those brackets. So you can deal with this all at once, or you can deal with it one piece at a time. So let's deal with it one piece at a time just to make sure I'm being really clear here. So that becomes negative, and now I have 2 of everything that was in there. So the first thing I'm going to do is, I'm not worrying about the negative sign, I leave that, but I imagine, so what would it mean if I had 2 of these brackets? And that's simply enough. Instead of x squared, that would mean I have 2x squareds. Instead of 2 positive x's, I would have twice as many of those. So that would be 4 positive x's. And then instead of negative 3, I would have negative 6. So that is the new bracket, but now I've taken the 2 and multiplied that in, but not the negative sign. So what does having the negative sign do? The negative sign changes the bracket into everything that was positive becomes negative, everything that was negative becomes positive. So this can take up a bit of room, but you can see that these positive 2x squareds become negative 2x squareds. These positive 4x become negative 4x. And these negative 6 become positive 6. One of the downsides that you can probably see here with algebra tiles is that it can get a little on the tedious side. You're counting out tiles, but remember, these are a visual aid. These are to help you out if you're not able to do some of these operations, or if you're not super comfortable with these operations entirely algebraically. So what do I have here? I have negative 2x squared minus 4x plus 6. And there is my final answer. All right, we're really going to start to see some of the limitations of algae tiles here. This is still doable, it's just it's going to start to get, you can see I'm overlapping tiles to try to save room. So my first bracket is 2x squared minus 2x minus 3 and then I'm subtracting from that this second bracket, and in the second bracket I have an x squared minus 4x plus 2. Now if I have addition, everything's fine, but because I have subtraction, what I need to do is I need to change the sign of what's in both of the what's in this second bracket, and change it to addition. So the subtraction changes the sign of everything in here and turns into addition. So I don't need to keep the bracket for this one anymore, this first bracket, so that just becomes the same thing. That's 2x squared minus, actually, you know what, we wouldn't normally do it this way, so we don't have that many tiles to work with. So why don't we say what we would normally do now is we would actually throw away this positive x squared and replace it with a negative x squared. This is going to become a plus now. We would throw away these 4 negative x's and replace them with positive x's. And we would throw away these positive 2 and replace them with negative 2. And once I've done that, now I don't need the brackets anymore. Now I can just combine them because I'm just doing addition. So a bit of cleanup. And now I combine these things. Well, a positive x squared and a negative x squared, these two things are going to cancel. They become 0. I've got a negative x and a negative x, a positive x and a positive x. So those are going to cancel. I've got negative 1, positive 2, positive 1, positive 2. And so that gives me my final answer is x squared plus 2x minus 1, 2, 3, 4, 5. And again, if you're feeling comfortable, you can go ahead and do this algebraically and confirm that that is the correct answer. Okay, now this is an interesting one, and this is really this is our target. This is what we want to get to. This time I'm multiplying x plus 2 times x plus 3. Now that's a little unusual. For example, we did something before where we were multiplying, for example, a number times a bracket. But what about an expression like this multiplied by another expression like this? So the way you do this is it's easier if you give yourself some guidelines to work with. And what I'm going to do is I'm going to take x plus 2, so that's positive x and positive 2, and I'm going to put that down one side. So that's x plus 1 plus 2. And you'll see these things line up in a certain way. Along the top here, I'm multiplying by x plus 3. So all positives. And now what you do is you are going to multiply, well, what you're actually going to do is fill in the shapes, but what you're effectively doing is multiplication. So what will fill in what I've created here? And when I say fill in, what I mean is an area. So I've got this x multiplied by this x, and the area that fills that in, and if you just think about algebraically, x times x is x squared. And you see how those edges line up. Now I've got this long x, and then I've got this little short 1. So what's going to fill this area where I'm tracing my pencil? Now the orientation of the shapes actually matters. So you can see that underneath each of those 1's, I'm going to get x's. This is a good time to discuss one of the rules for algae tiles or algebra tiles is that the edges of tiles have to line up with whatever they're next to. So you can see this x has a long edge here that must line up with the long edge of the x squared, long edge to long edge. On this x, short edge lines up with that 1, long edge lines up with the x squared and also lines up with the x. So you can see all of these edges are long and vertical. Here we have long and horizontal. And now what about down here? I've got the short edge from a 1 and the short edge from a 1, and of course 1 times 1 is simply equal to 1. So I have 3 short edges there and 3 short edges here. And so this product, x plus 2 times x plus 3, is equal to, I just look at this shape that I have created. Make sure you don't include the original x plus 2 and x plus 3. They were used to create this shape, and this shape has an x squared in it. It has 1, 2, 3, 4, 5 x's, and it has 6 constants. This is known as an area model. We are using the algebra tiles to create, using x plus 2 is one length of the rectangle, so that's the length. X plus 3 is the width of the triangle, and my answer here is the area. And we're familiar with that formula. Length times width is equal to area. When we're using algebra tiles for this specific purpose, that's all we're doing. And we're going to do a bit more of that. So let's use that area model again. Give myself a framework to work with here. So the first one is x subtract 3. So put a negative 3 down that one side. And the other one is going to be x plus 1. And so an x times an x gives me an x squared. A 1 times an x gives me a positive. Now this is where things can get interesting as well. Remember your rule or your rules for multiplication. If I multiply two positive things together, my answer will be a positive. A positive times a negative gives me a negative. A negative times a positive gives me a negative. And a negative times a negative gives me a positive. Now that being the case, we apply the same thing here. Remember, negatives and positives mean changing the sign or changing the color. So here I have a long edge, which is red, and I have a short edge, which is blue. So a red times a blue, that's going to be a positive times a negative. The answer to that is going to be negative. And so I need a long edge and a short edge, and red times blue gives me blue. Red times blue gives me blue. And finally, red times blue gives me blue. Now, what about over here? I've got a positive 1 multiplied by a negative 1, which is equal to negative 1. I just want to highlight that. What I'm doing is taking this multiplied by this, and they come around together to put that tile in place. And I'm going to need a couple more of those. And we check for consistency. We make sure things are lined up the way they're supposed to. The edges match. And in this case, we have our answer, which is we have a positive x squared. Now take a look. This one we might actually want to separate out. Now that I've got my answer, I'm just going to separate that out because I want to show you the x squared is on its own. But notice I've got an x and a negative x. So those two are going to drop away to be 0. And then I've got negative 2x and negative 3. So this is minus 2x minus 3. And that's my final answer. I could have written that if I go all the way back to what I had before. I could have written this out, x squared, and then I could have said, well, there's a positive x here, and then there's minus 3x's there, and there's minus 3. But what do you notice about positive x minus 3x? That's just the same as minus 2x. So this is equal to x squared minus 2x minus 3, which is the result we got when we noticed that these two are going to add up to 0. X squared minus 2x minus 3. 2x minus 1 times x minus 2. Now for this one, I think I might have to, just for the sake of room, I might have to switch things up. So what I'm going to do is I'm going to put my 2x along the top. This is another limitation of Algebra Tiles. They're very great tools, but they do have a limitation in the fact that they take up some real estate. You have to have some room to work with them. So there's my 2x minus 1 across the top, and I've got x minus 2 along the side. And now go ahead and fill those in. Positive x times positive x gives me a positive x squared. Positive x times positive x gives a positive x squared. I've got a negative 1, a short side, and a long side. So that's red and blue. So that's a positive and a negative. That's going to make a negative. But you have to make sure those edges line up properly. I've got a blue and a red and a blue. So that's this and that red and a blue there. I've got a red and a blue. So that's going to give me a negative, positive and negative. And then this one's interesting. First time we're seeing this. I've got a negative 1 times a negative 1. A blue and a blue, the same color, produces a positive. A blue and a blue, same color, produces a positive. I take a look here. There's actually nothing that adds to 0. There's no positive and negative terms to cancel out with each other. So I go straight to my answer, which is 2x squared. I've got minus 5x's plus 2. Two x minus 1 times 4 minus x. Now this one's written in a slightly unusual way, but we can go ahead. The Algebra Tiles, working with the tiles, they can manage that. They'll still get us to the correct answer. Just be careful. 2x minus 1. Again, I'm going to lay that out the same way I did before. 2x minus 1. 4 minus x. 1, 2, 3, 4, and minus x. So even though this is unusual, it actually is still going to work just fine. But we have to follow our rules, which is we've got a long side x and a short side on the 1, so that's going to be red and red gives me another red. So that's going to give an x. That one will give an x, and an x. Long side to long side, short side to short side. Now I have a long side to long side. Well, that's going to be one of the big squares. But it's blue and, sorry, it's red and it's blue, so that means it's going to be one of the big squares in blue. Long side to short side, red and red gives me red. Long side to long side, red and blue gives me blue. Short side to short side, but different colors gives me blue. Short side to long side, but in different colors gives me red. Now that's a bit unusual, but we've been consistent there. Now this isn't normally how you would represent a question like this. More conventionally, you might represent this as 2x minus 1 and then negative x plus 4. Those are equivalent. 4 minus x is the same as negative x plus 4. But the answer here actually is correct. First of all, check and see if there's any terms that you need to cancel out by adding to 0. There are none. I have my answer, which is equal to, I have negative 2x squared. I have 4, 8, 9 positive x's, and I have 4. Just make sure when you do this, remember these tiles and these tiles were part of the original question. They don't get added in. The only tiles that get added in are the ones we use to form the area here. I don't think I can pull that out cleanly. So these tiles are the ones that we make use of when we're doing our final sum. We don't use these ones up on the edges. And I believe, yep, that was our last question. So that's a very quick set of problems using algebra tiles. Practice with them if you can, and see how you can relate them to your algebraic practice on paper.